Hey everybody, welcome to video 2 on radicals and conjugates. Now we're going to get into simplifying some radicals, and we're going to do a couple of examples here in this video. And so we're going to go ahead and simplify 5 times the square root of 72 times x cubed. X is going to be greater than or equal to 0 because we can't have any negatives under our radical. Okay, so here's what we're going to do. We're going to break down a couple of these things. We're going to take 72 and we're going to break that down first. So 72. Okay, that can be broken down into 9 times 8. Okay, 9 can be broken down into 3 times 3, and both those are prime, so this branch is done. 8 can be broken down into 4 times 2. This branch is done, and 4 is broken down into 2 times 2. So, 72 is equal to, I have 2 times 2 times 2, and I'm going to leave it as 2 squared times 2. Times, I have 2 3's here, and that's 3 squared. Okay, so all my numbers are used. These are my prime factors, and that's how I write 72. Now, x cubed, over here in my scratch work, x cubed is still equal to x squared times x. That's x cubed. So when we rewrite this problem, we're going to go ahead and leave the 5 out front times the square root, okay, of our number, which was 2 squared, 72, 2 squared times 2 times 3 squared. Okay, and then we're going to put x squared times x. Now, anything that's raised to a power of 2 is coming out because this is a square root. That little index is a 2. We just don't write it. So, let's look through. 5. Now, the 2, these are just going to cancel. It's like when 2 become 1. All right, 2 squared. That 2 is coming out. Okay, so I took care of that check mark. 3 squared, that 3 is coming out. Check mark, took care of it. X squared, that x is coming out. Awesome. That's everything I can take out. Okay, little check mark there. Whatever's not checked stays in there. Notice I have 2 and an x. So underneath is just 2x. And now let's multiply 5 times 2 times 3. That's 30. 10 times 3 is 30. You get 30x times the square root of 2x. And that's the simplified form. Now, the next one I like here, tip: if a variable has a large exponent, you may want to use the following shortcut. Divide the exponent by 2. The number you get becomes the exponent outside the radical. And if there's a remainder, that stays inside the radical. So let's look at number 4. Okay? Express square root of 54x to the 6th, y to the 9th in simplest radical form where x and y are positive. So, let's start with 54. 54 is 9 times 6. 9 is 3 times 3. Those are prime numbers. We're done. 6 is 2 times 3. Whoops, we don't need that times there. So those are prime numbers. 54 is done. Now let's use our hint. X to the 6th. Break it down. Okay. Well, 6 divided by 2 equals 3. Let's look at y to the 9th. Y to the 9th. Now, 9 divided by 2 equals 4, and then you have a remainder of 1. Okay? So watch what happens when I simplify that. Okay? Sorry about the phone call there. Watch when I simplify this. We're going to go ahead and we're going to take our radical, and we're going to rewrite. We have 3 times 3, 3 and 2. So let's do 2 times 3 squared times 3. Okay. And now, look what happens. We divided x to the 6th, and we got an even number 3. So x cubed comes out front. Y to the 9th, unfortunately, isn't divisible by 2. We had 4 with 1 remaining. So y to the 4th comes out, and we leave 1 y to the first power underneath. And that's what this means. Look up here. Divide the exponent by 2. The number you get becomes the exponent outside. Look, we divided by 2. The number you get is the exponent outside. 3 here and 4 here. If there is a remainder, whatever the remainder is, goes underneath with the variable. So let me clean this answer up a little bit. We get x cubed times y to the 4th and then we get, oops, we didn't even take the 3 out. That 3's got to come out. I apologize. So 3 comes out. So 3x cubed y to the 4th, and then the 2 and the 3 stay. We get 2 times 3, which is 6, and then we get y here. Almost didn't finish that problem. Sorry, everybody. So just in closing, the 54 breaks down. There's our product of primes. That 3's coming out because it's a power of 2, and that index is 2. We just don't write it. This 2, this 3 stay. 2 times 3 gives you the 6. We have 1 y left over, and that comes from over here. Okay, so if you have any questions or comments about this example, please let me know, and we'll see you next time.